All right, gang, for the last piece of chapter 4, I want you to get in your books and look for figure 4.8. It's right at the back end of the chapter. Again, if you're looking at regular numbered, it's page 112, regular numbered pages. But otherwise, figure 4.8, like I said, it's right near the very end of the chapter. And what you're going to see there are two modified histograms, two graphs, one on the left and one on the right. Each graph has two samples. So go ahead and pause the video, make sure you go get to that page. Okay, the colors vary in student versions and teacher's version. Mine, they look kind of beige and blue. Some students, they're other colors. But there's two different samples. Let's look at just the left side, the figure A, if you will, for 4.8. We can see that there's 4 blocks, 4 scores in the brown or the beige sample, and 4 blocks in the blue sample. And what we want to ask ourselves, and just don't worry about the numbers, just look at the graph, look at the pretty picture for a second. The question is, did the two samples score differently from each other? Did one sample score higher or lower than the other? And the answer should be pretty obviously, yeah, the blue sample scored higher than this beige sample. I've got one set of blocks over here and one set of blocks over there. It's pretty easy to tell that their scores as groups are different from each other. This sample scored lower than that sample. And now look above it and you can see that treatment condition 1, that beige group, has a mean, that sample mean of 35 points, the lower one, and the other one has a mean of 40 points. So the math verifies. Yes, they scored 5 points differently from each other. Now look at the other graph on B. Same setup. We've got two samples, a beige and a blue. And the same question applies. Just again, ignore the numbers. Just looking at the blocks on the graph, did the samples score differently from another? Is it obvious to you that one of those samples scored lower or higher than the other? It should be, for most of us, a whole lot harder to tell now. We don't have one neat stack here and another neat stack there. It's like someone came by and kicked it all over. There's blocks all over the place. It's kind of an intermingled mess. On the first graphs, those samples have low variability. All the scores for the brown are pretty close to each other. All the scores for the blue are pretty close to each other. But in the second graph, that's not true. There's high variability. The people in the brown sample scored all over the place, and the people in the blue sample scored all over the place. Just looking at it, it's harder to tell in the second example that if one sample scored higher or lower than the other. And now looking at the top of it, you can see the actual sample means are the same as the other example, 35 points versus 40 points. So the amount of difference between those two samples is actually identical. But in the first example with low variability, it's easier to tell that. In the second example, where the samples had high variability, it was harder to tell that pattern. So there is a connection between how much variability is in your data and the error we're going to have in understanding any patterns in our data. Error is a big deal in the world of statistics. We're going to have multiple types of error and definitions and formulas for it. Error is our enemy. On the whole, if we are, say, trying to evaluate, does this medication make a difference in treatment of, let's say, cholesterol? Well, imagine if everybody has a different reaction to it. Some people take the pill and their cholesterol doesn't change. And some people take the pill and their cholesterol changes quite a bit, drops significantly, drops precipitously. Other people take the pill and somehow it backfires and their cholesterol goes up. Well, if the question is, what does the pill do? You're going to have a hard time answering that question if there's a lot of variability in the responses to the pill. It's going to be hard to say that, oh, this pill treats cholesterol if everyone's having kind of a different reaction to it. But now imagine that we're giving the same, or a different pill, I guess, or to a different sample, and that person's cholesterol drops by 10%, and that person's cholesterol drops by 10%, and the next person's cholesterol drops by 10%, and the next person's cholesterol drops by 10%. If everybody's having the exact same response to the pill, there is no variability in their reactions to it, then it's really easy to say, what does the pill do? Oh, it lowers your cholesterol by 10%, apparently. That's really a much easier conclusion. So variability is associated with error. if we have a situation with high variability, the result is increased error. Again, increased error when it comes to looking for patterns, for understanding what's in the data. And of course, then the opposite would be true. If variability is lower, then we have less error. Let me give it to you in a different example. Let's say we were in a room together and I have brought into this room 10 different radios. And I tune them to 10 different radio stations and I turn them all on. So you're sitting there listening to 10 different radios play 10 different stations simultaneously. What do you hear? The answer is probably noise. It's going to be really hard to figure out, make any sense of it, because there's a lot of variability in what your ears are picking up. Each station is giving you different information, and it's going to be hard to make sense of it. Now, I turn them all off, and I retune all these 10 different radios to the exact same station. Now, they're all programmed to the exact same station. I turn them back on again. What do you hear? Oh, it's going to be very easy now to tell what you're hearing because there's no variability. All the radios are playing the exact same programming at the exact same time, so there's no variability. So this will eventually become a much bigger deal in this course. So really, like I mentioned earlier, I'm just sort of planting a seed about this. So this is something you really need to know, but this is really going to grow into a much bigger topic for us as the semester goes by. So the more variability we have in our data, the more error we have in recognizing patterns in that data. The less variability we have in the data, the less error we have in finding and recognizing those patterns. All right, my friends, this finishes up our lecture series of lecture clips for Chapter 4. So as always, get into doing some homework, pay particular attention to the lab problems I select for you, and as always, questions you've got for me, hit me up with an email or a Canvas message, and I'll be happy to help you with anything you need. All right, I hope you're having a good semester, and we will see you next for videos for Chapter 5. Bye.